So today we're going to talk about polynomial graphs. Before we look at any graphs though, first we need to look at actually what defines a polynomial, what qualifies to be a polynomial. First of all, it has to be a function. You guys have talked about functions the last couple years, so I'm not going to expand on that right now. It has to have positive integer exponents. This is the most important qualification to look at. All of my powers have to be positive numbers and whole numbers. It has the general form of the equations that we've been working with. You've got coefficients, you've got powers, you've got variables, and we have varying powers until we get down to our constant at the very end. So how about this first example? Does this qualify as a polynomial? Look at the powers, look at the format. All of my powers are positive and they are whole numbers. I have coefficients, variables, and powers of varying degree. So in this case, this is a big yes. My next example though, I should have erased that part first. If you look at it, the power itself is not a whole number. It's not an integer. So that in itself is enough to say, is it a polynomial? Well, big resounding no. How about a polynomial, or an equation I should say, with a root in it? Well, if you recall, a square root is the same as x to the 1/2 power. So that square root itself makes this not a polynomial. So moving on, now we're going to take a look at some graphs of polynomials. I want you to take note of the shape and the degree. So here we have a second degree polynomial. The important things to note here is that it's a second degree polynomial. It has a positive leading coefficient. The 3 is positive, and it's an even degree. If I change that so that now it has a negative leading coefficient, it looks a little different. It still has the same basic shape, it just points in a different direction. It still is an even degree or second degree polynomial. Next, I have y equals 3x to the 5th. It's important to note here that this is a 5th degree polynomial if you look at the basic shape. It has a positive leading coefficient and an odd degree. If I change that graph so that it has a negative leading coefficient, it actually points the opposite direction. It still has an odd degree. Look at the difference between the two. Positive leading coefficient, negative leading coefficient. Here's a couple more examples. Here I have a 4th degree polynomial, one with a positive leading coefficient, the other with a negative. They both are even degree polynomials, and that's going to be a big deal to us today. Next, we're going to look at some 5th degree polynomials. Notice that one has a positive leading coefficient, the other negative, and they're both odd degree polynomials. Next, we have some more 6th degree polynomials, one with a positive leading coefficient, one with a negative. These are both even degree polynomials. Some 3rd degree polynomials, one with a positive coefficient, the other with a negative, and they're both odd degrees. Are you starting to see a pattern here? Let's group them a different way and see if we can find the pattern. First of all, here's 2 of our graphs that we looked at with positive leading coefficients and even degrees. Notice the shape. Even though the shapes aren't exactly the same, do you see that they both curve and are concave up? Here's some even degree polynomials with a negative leading coefficient. They still are kind of curves, almost like our quadratic functions, and both of these are concave down. Here's some more examples with a positive leading coefficient and odd degrees. They're not identical by any means, but they do have the same basic shape. And here we've got negative leading coefficients with odd degrees. What we want to be able to do with all of this, for now anyway, is be able to identify which graphs have an even or odd degree and a positive or negative coefficient. So for instance, here I have a quadratic function. I want to know, do you think this has a positive or a negative leading coefficient, and is it an even or odd degree? From our examples before, this should have a positive leading coefficient and an even degree. How about this one? Positive or negative, even or odd? This one would have a positive leading coefficient and an odd degree. How about this one? Negative coefficient, odd degree. And finally, does it have a positive or negative leading coefficient? Is this an even or odd degree? This one was one with a negative leading coefficient and an even degree. We're going to explore more about these polynomial graphs, but for now, that's enough. Good luck, and I'll see you next time in class.